Welcome back. Today we're hopefully going to be working on this stack control update, because right now if we take stones out of a stack, its stack control still just defaults to whatever it last was. So we want to, anytime we make a change in stones, basically, yeah, if we lock in our first stones dropped, then we need to assign stack control appropriately. So we have to figure out how to implement that. I can't code longer than 12:55 today because I gotta get back to work, but I've got an hour break. I'm thinking I might want to change this first movement stones dropped, because what this is actually signifying is the amount of stones we it's like we've locked in how many movements. See, because it's like we haven't really dropped any yet. It's just something that we've picked up. So if we pick up 5, we pick up 5 by clicking on it, then we drop 3 so that we only move 2. That would be saying first movement stones dropped gets true once we lock in that we only picked up 2 stones or whatever. So I think I want to change that to something else. First movement stones dropped, it's more like we lock in how many stones we pick up. So like first movement stones, yeah, what do we call it? What makes more sense than first movement stones dropped? It's like we just lock in how many stones we pick up. So like first movement stones locked. I don't know. I guess that's... I don't like dropped because we don't drop them in the place that they came from. We're just only picking up 2. Just the way we coded it, we pick up 5 and you have to drop however many you want. So maybe instead of first movement stones dropped, we say first movement stones locked. So first movement stones locked. Because I just don't like the dropped terminology there, because they're technically not dropped in that movement origin grid, they're just placed there. They're picked up, dropped into that grid, so we're only picking up the remaining. Okay, so yeah, we only lock that in upon pressing an enter. If we're in a move type move and our movement origin is locked. Yes. Okay, so that shouldn't crash anything. So it's our move, we click on it. We drop a stone. Can't drop another stone. Now if we lock in how many we've dropped, oh god, this is broken now. Stack control's busted, but legal moves busted. Oh god. When did that break? gosh, oh gosh, oh gosh. Are there any other ones? Oh, here. Maybe we just did it here. Yeah, we don't populate our legal moves without first movement stones locked. Okay. Now let's see if those legal moves render at least. Nice. Okay, we're back to that working. I'm gonna print up whether or not we're on our... What is it? First move locked. First movement. Stones locked. First movement. I'm just gonna say first movement locked to a string. We get our variable as a boolean printed as a string. Now we should be able to see it. Should print up on screen right there. First movement is false. And then as soon as we hit enter, that first movement will become true, which then it should allow the rendering. So we've got that printing up now. Now we need to change those occupant stack control. Now there's two ways we can go about this. We can either brute force cycle through every single grid, every single frame, and populate the stack control based on the color of the highest index member of that stone. That's one way to do it. Another way to do it is anytime a stone is placed, we assign the stack control. And then anytime a stone is moved, we need to nullify the stack control unless there are still stones remaining in the grid. So there's a bunch of different things to consider, but basically we populate the stack control on a placement in an empty space. That's easy enough. Now if we move that stone out of a grid, if there's only one stone and we move one stone out of a grid, we know we need to nullify where the grid came from in terms of stack control and stone type and stone color. But we need to also populate stack control appropriately based on when our stones move into a spot and when our stones move out of a spot. So I'm gonna write a function, I think, called getStackControl. A function called getStackControl that takes in a occupant, right? Because an occupant has 10 members and it's going to cycle through starting from the 10th downwards. And anything that isn't nil, as soon as it's not nil, it'll populate, it'll return that stack control value. That function will return that stack control value. So maybe we write a little function here in our play state. Just like we have this reset board function, we want a function called getStackControl. Takes in no arguments. No. It would need to take in an occupant type. And an occupant has members, so I think we can just put occupant there, and then we say that we can say we want to decrement for loop in this case because we want the topmost stone stack control. So for I 10 to 1 minus 1, do something, and the something we're doing is saying if occupant dot members at index I, if that does not equal nil, then it is the topmost populated stack. So we would say we want to put occupants. I'm actually not sure how to have a function in Lua that returns a value. Let me look that up real quick. I guess instead of returning a value, we would just run I think since Lua is a scripting language, it's a little different than something like C in the sense that, like in most language, a function can't return a variable, only a value. Yeah. I guess I'm confused. Oh, you can just return it here. You just return whatever value you want, and then you can do whatever you want with it, I guess. So instead of returning a value, what do we want to do? We want to modify that given occupant's members index at it's actually just the occupant in the stack control field. That occupant. But the thing is, we need to, do we want this function to only cycle through one occupant? And yeah, I think we want it to only cycle through one occupant. So we pass in an occupant, and that occupant will have to have 10 members indexes, which they all do. Then we go through a loop decrementing from 10, And we only modify stack control if the members at that highest index is not equal to nil. And as soon as it is not equal to nil, then we populate the occupants.stackControl with well, it would be its color at that index. So that occupants members at that index, its stack order. So we take the members at that highest index, we take its stack, not stack order, stack control. We take its stack control, we assign it into, see, this isn't right. This is actually stone color, because our stack control is only in our occupant class and our stone colors in our member class. So we take the color, which should be a string, and then we assign it into the occupants stack control field, which should be a string. So as long as we run this function with, I guess I don't need to write this as play state. Just like how reset board only was like that. So this function called stack control takes in an occupant. And what it's doing is it's assigning the highest member's stone color as that occupant's stack control, which is what we want if there are no logical bugs there. And then I guess we want to return to get out of that loop once that member's nil. Is that right? Because we don't want this for loop to go all the way through all the numbers. We just want it to hit the first number that's not nil, assign it, and then exit. So does this return do that? I guess we could figure out that. What I'm gonna do is turn off all assignment of stack order on our grid 1-1. And now our grid 1-1 stack control should be nil. Oh. It's actually stack control is what I'm trying to do. Stack control, we're turning off stack control. Out of our grid 1-1. So now if we hover over it, our control is nil because we just nullified it. So now I'm going to try to run this function, getStackControl, on our grid 1-1 and see if it works. So in our update function right here, I'm just going to say, by the way, run your getStackControl function on an occupant, and the occupant I want to run it on is our grid 1-1 explicitly, which is a instantiation of an occupant type. And that occupant type will have members field, a table of members, so it should be able to run this. So let's see. Stack control still nil. Now that occupant that gets passed in, its stack control shouldn't be nil at that point. Maybe grid 1-1. That should be the one. It's working now. Once I took out that return. How come a return there breaks it? Doesn't even get to... Huh. I don't know how returns work in Lua. But... how would we... I don't want to check more than one stone. I just want the first legal stone. Because right now, stack control... Oh, great. I need to save it. Right now, stack control is white, but it's not because the top stone is white. It's because the bottom stone's white, because it's going through all of these. So how do we do a for loop? How do we exit a for loop prematurely in Lua? I thought you could just return. Or maybe we say return this, and that'll be the end. No. I don't know how to exit a for loop prematurely. You can use the break statement. You can use the break statement to finish a loop. Breaks the inner loop that contains it. Cannot be used outside a loop. A return statement returns occasional results. Okay, so it's not that I want to return a value, it's that I want to modify a value. So we modify it by assigning it right here, and then we want to break. So now, hopefully, it would still say the same thing, but it'll actually be correct now, because it's not going to the end of the stone. It's still broke. Why does break it? If the member does not equal nil, I guess it's not that anything doesn't equal nil, it's that its stone color would not equal nil. Maybe that's right. Let's see if this just works, and then we'll add the break back in. Okay, it's working on white now, but if we add the break, does that break it? No. Okay, so it looks to be working now. We can test this by adding... we want to add a stone of a different color than the bottom stone onto the top there. So we'll just add another stone. And that stone will be a black laystone at members 4. We're not assigning stack control, but we're assigning the stack order. So now there should be a black stone on top. And then it should be, our function should now return black, which it does on our stack control. So it looks to be like that function's working correctly now. So now we can run that function on any grid, and it'll give us in a string the stack control of that occupant. which is right here. We do this break. Okay. So all we have to do is run this stack control on any grid space that we had just modified. So like, I guess let's just do it. Get stack control, easy enough. So if let's see, if we hit enter, we need to get stack control of both the origin grid and our mouse stones. No, our mouse stones doesn't matter. We just need to lock in what our movement grid stack control was. So right now, if we're to move type move, oh no, I forgot to update stack control. Okay. So right now, if we drop a stone so a black is on top, which is the opposite of what stack control currently is, if we hit enter to lock in our first moves, our first stones locked, first movement stones locked, that needs to be black control now instead of white. So we need to run that function on the movement origin grid that we just did upon pressing enter. So like pressing enter locks in how many stones are in our movement origin space, but we need to modify our movement origin space, which is what? Our movement origin row and our movement origin column. That field, well, we need to say this is the occupant in which we want to run our get stack control function on. We run it on that occupant, which will modify that occupant's stack control to be the highest color stone occupant. So now, if that all works correctly, it will update. If we leave a black stone there, control is white. If we hit enter, control should become black, which it does. Cool. Cool. So anytime we lock in stones in a position, we need to run that stack control function so that we just get we just update the proper stack control color for that grid. So this to me is way better than my other idea of brute forcing it, right? So instead of 60 times a second running through every single occupant, every single member and every single occupant, looking for the highest stack ordered stone, getting its color, and then assigning the stack control based on that, we only update stack control based on a change in stones. So we only do it once right here upon locking that thing, and we do it upon placing stones too, which if we're up here, we place a stone, we get stack control based on what type of stone was placed. Yeah, stone select. Yeah, if stone select is 1, if stone select is 2. Okay, yeah. So yeah, we assign stack control once we place it. It'll probably be on a move, on a click detection in a move type move, which is, oh, that is exactly what it is. Okay. Okay, so that's nice that we fixed this. We need to add the first movement place to drop stones. Okay. So we need to do something called lock in second movement. Or lock in first placement? No. It's so hard to decide what to name this stuff. Let's take a look at our variables here. We've got movement origin locked, which is the space where we originate our movement, which is where we're picking up stones. So then we would need a first movement grid locked, like the first grid you move to, or do we call it something else? Not exactly sure. You call it something like first movement stones locked. First movement grid locked. Yeah, I think we should call it first movement grid locked. Because first you lock in how many stones you're moving, then you lock in the actual movement, which determines actually this is a little confusing because the first movement stones locked is the amount of stones that are in your hand before you've moved to them. I feel like I want to change this variable again. We changed it at the beginning of the episode, but I think I want to change it again because we're not locking in the first movement stones. We're locking in the stones in hand locked or something. Stones in hand locked. Initial stones in hands locked. I don't know. Stones in hand locked. So this first movement stones locked needs to be now equal to this stones in hand locked. I just don't want it to get confusing because there's going to be a first movement stones locked right when we initiate where that stone moves, because we have to decide how many gets dropped. So I need it to be something different. And I don't want to muddy up the first movement variable's namespace, because technically the first thing we lock in is just how many stones are in our hand. It's not anything to do with our first movement, other than how many stones are available to drop in that first movement, but we still have to decide that. So I think it's better to name it different. So first movement stones locked need to become stones in hand locked. So first movement stones locked becomes stones in hand locked. I'm gonna have to change this again, but that's okay. Okay. So we're locking in how many stones are in our hand. Then when we click on a legal move, once our first movement grid is locked. So first movement grid needs to be locked as soon as we click in an illegal move once our stones in hand is locked. Yeah, we just have to remember to flush these values upon a switching of a turn. But that's okay. So we've got, if it's in a move type move, and not movement origin locked. So this is like the pieces of what our move type move logic is. This is a little confused why all of this is outside of the click detection, because here our click detection is happening right here. If the actually, yeah, no, that's right, that's just for placement and the first move. Actually, oh, this is what? Okay, I'm gonna have to think about how to do this, because right now we're kind of cutting off some of our other code, like down here. We're not really checking for clicking at this point. Oh, okay, yeah, we're not checking on clicking, but we are checking for the keyboard pressing. So we need to check for clicking again once our stones in hand locked is true, and our movement origin grid, or our first. Yeah, I'm gonna have to write out all the different variables for the types of moves because I'm already confused, but we'll have to add it here. This is for like keyboard pressing for first stones dropped. Lowest milestone stack order, I guess that's okay to do this. Legal move 1, highlights. See, because we need to change the what we highlight based on. Oh, see, I don't like this. Okay, no. This is okay. Yeah, this is hard-coded for the corner cases. So if our locked in row, okay. So I guess whenever we click on a new space, whenever we drop in however many new spaces, as long as we still have an occupant in our mouse stones, we would need to update our move locked row to not be our movement origin grid, but to be our first movement grid space. So we'll have to make sure we do that. Leave us a little note here for that. Make sure movement locked row and grid is updated once first movement grid is clicked. So right now, the very first thing we're doing is checking for button detection. if you actually click in something in an actual grid, but we need to modify some things. Well, I guess we do it right here. And not movement origin locked. We can add this not movement origin locked to the top here. Yeah. Yeah. Okay. Because we have to use these booleans to kind of toggle the order of operations for the different highlighting, because depending on whether or not you've locked in your stones or depending on not you've selected your first movement grid, all affects what renders as a legal move. So we have to just manually kind of keep track of that sort of stuff so that we do it right and render the right things. I've got to get back to work very shortly, so I'm gonna commit for the day. I might be back later today to add another video, because today was kind of short. But if we look at our getDiff, we changed some variables. We made a function called getStackControl that takes in an occupant. It modifies that occupant's stack control to be the highest member in that occupant's member table. Its highest most stone color gets assigned into that stack control. And then we just changed some of those variables again, the name of those variables. So git add everything, commit with a message saying added getStackControl function. Runs after any change in stones within a grid. Any locked in change. Any locked in change in stones. Any locked change in stones within a grid. Okay, git push it. There we added some functionality. We're about to implement our first movement from a stack. So we have the stones left in our hand, and we now get to click an illegal move and it'll lock in our second movement or our first movement grid, because there's the movement origin, then the first movement, and then we'll also render that first movement as a dark green. But then once you select that, you have to decide how many stones you drop, and then once you lock that in, we'll modify the stack control for that new grid, and then we lock in the direction of movement for our grid so that only legal moves can be only in that line as long as there is no capstone or laystone in front of you or off the grid. And we also need to ensure that if the space in front of you, the only legal move at that point, is a blocked capstone or laystone or off grid, that you need to drop all of your mouse stone members in that grid, because that's the only legal move. And then maybe we can worry about undoing something if you undo that. I don't know how to exactly do that, but we'll try to do that, because like ideally you would pick up a whole stack, start moving them, and then get to the end and realize, oh, I should have dropped another thing. So yeah, I guess we have to determine when to switch the turn, because if there's no legal moves left, it'll place all the stones and then switch to the other person's turn, as it should, but then that means you can't undo, so we'll just worry about undo later. But those are some of the things coming up next.